So in this video we're going to be maximizing profit. Just a reminder, profit is revenue minus costs, which we read as P of X equals R of X minus C of X. And revenue generated is going to depend on the market situation. So revenue depends on the market. There's two kind of markets to consider. So one, if the market is competitive, the seller does not control supply, and thus can't control the price, and must use the market price. Picture here illustrates what's going on. So we have a demand curve which goes down, supply curve which goes up, and the place where they intersect is called the market equilibrium price, P. And in a competitive market, this price is fixed. So the revenue here is going to be, the revenue in this situation is going to be P, this fixed price, times X. This is just a number. It's a fixed price determined by the market. All right. If on the other hand, the market is controlled by a monopoly, market is controlled by a monopoly, this one seller, this monopoly, controls the supply, and thus they can set the price. To maximize their profits. And the price can be described by this demand curve, and it's a function of X. It's a function. They can move this point up, lowering the amount that people buy, but increasing the amount they get for that. Or they can move it down, lowering the price and increasing the amount that people buy. So it's this function, P of X. So in this scenario, in this monopoly scenario, the price is a function. Okay, so let's look at an example. Call this example 1. So suppose the per unit cost of a toaster produced by some factory is C bar, average cost is 25 plus 0.1x. All right, and let's think of two scenarios. So if the market is competitive, and the fixed price, the market equilibrium price, is $50, how many toasters should the factory make to maximize their profit? And then B, if the market is controlled by this company, so if the factory, this company, has a monopoly, And the demand curve is given by this function. Price equals 100 minus 0.05x. What amount should factory produce? And price they should set to maximize profit. So you'll note in the monopoly situation, you can set a price, unlike in the competitive market situation. Okay, so let's do this problem. So part A, we're going to have profit is revenue minus cost. Profit is revenue minus cost, and the price is fixed, so the revenue is going to be just the fixed price, $50, times X. And the cost, well, the cost is given by this little preamble here. The average cost is 25 plus 0.1x, so the cost is going to be the average cost times X. And I'll just remind you why this is true. So the average cost is the cost divided by X. So the cost is going to be the average cost times X, just solving for costs in that. Okay, and so the cost was 25 minus 0.1, or plus 0.1, excuse me, X. Multiply by X, we get 25X plus 0.1X squared. So we have revenue of 50, and we have a cost of 25x plus 0.1x squared. So the profit function is going to be 50x minus 25x plus 0.1x squared, which is 25x minus 0.1x squared. We can maximize this by taking the derivative. So the derivative of this function is 25 minus 0.2x. Set it equal to 0, we'll get 0.2x equals 25, or x equals 25 over 0.2, which is 125. So in this competitive market situation, to maximize this profit, we want to, the factory wants to produce 125 toasters. And you could sketch the profit function if you'd like, and see that this is indeed the maximum. 125 is right here, and the function has a max there. And the max, if you wanted to compute it, is the profit here is 15.62 and 50 cents. That's the profit. The question does ask us for how many they should produce, the x value. So the x value, we will box that as our answer. Okay, so that's the competitive market situation. Now let's revisit this question with the monopoly situation. So in the monopoly situation, profit's still going to be revenue minus cost. The cost is still going to be this cost that we derived earlier, which is the 25x plus 0.1x squared. The revenue, however, is going to be not 50x. The revenue is going to be the demand, the demand curve, the price curve, times x. And the price curve is this 100 minus 0.05x. So we're going to put in 100 minus 0.05x, it's x, and we'll get 100x minus 0.05x squared. Okay, so now we have our profit. Our profit is going to be 100x minus 0.05x squared minus 25x minus 0.1x squared. And if we combine like terms, we'll get 25x minus 0.15x squared. And we can maximize this by taking the derivative. So the derivative is 75 minus 0.3x, setting equal to 0, and then moving terms around until we solve for x. Until we can solve for x, and we'll get x equals 75 over 0.3, which is 250. So in this situation, we should try to sell, the factory should try to sell 250. This is their goal. Produce and sell 250 toasters. And the way that they can get the 250 toasters bought is by setting the price at 100 minus 0.05 this 250, which if you put in your calculator, you'll get 87.50. So this is the price they should set. And again, you could graph this function. If you wanted to see that this is max, you could graph this function, and you'd see that it has a max at 250. It has a max at 250, and that max is $9,375. All right, I hope you found this video useful.